Welcome to the Holistic Psychiatry Podcast. I'm Courtney Snyder, a physician and holistic child and adult psychiatrist. Today's episode is part 2 of a 2-part series on situations in which we have too much neurotransmitter activity. In the last episode, I talked about overmethylation being one example. I also talked about the specific neurotransmitters serotonin, dopamine, norepinephrine, and epinephrine. If we are high in these neurotransmitters, we can struggle with anxiety, panic, insomnia. We can also have pain, high blood pressure, increased heart rate, and in extreme cases, psychosis or paranoia. In today's episode, I will be focusing on situations in which neurotransmitters are not effectively broken down, and I'll focus on 2 genetic variants, one the COMT gene, and another is the MAOA gene. And both of these have variants that are quite common, and certainly relative to overmethylation, these are very prevalent in the general population. And I'll talk about how we might recognize that these are issues for us, how this can be evaluated through testing, and ways that we can mitigate some of this excessive neurotransmitter activity. So we have at least 2 genes and more, but I'm going to focus on these 2 primary ones that we know about that make enzymes that are responsible for breaking down neurotransmitters. So remember that our genes are responsible for making a protein, and many of those proteins are enzymes. And in this case, enzymes that I'll be focusing on, their job is to break down these neurotransmitters. So if we have a variant on either of the 2 genes that I'm talking about, and the gene is not producing effective or ample amounts of the enzyme, then we can have high neurotransmitter activity. And we can be born with a very weak gene, or our gene may be fine, but when under certain stress or toxicity or imbalances in our microbiome, it may not be working up to speed. So the 2 genes that I'll be focusing on are COMT and MAOA. And not only can these be slow or sluggish, they can also be fast. And part of what determines this is where on the gene that variant is, if we have one, or we could have both. And there are even times when there's a fluctuation between this particular gene and this enzyme working fast or slow. For the purpose of this episode, I'm talking about the slow version of these 2 genes. So to start with COMT, this gene is responsible for making the enzyme catechol-O methyltransferase. This enzyme deactivates dopamine, norepinephrine, and epinephrine. It's also responsible for breaking down catechols, which are in green and herbal teas, coffee, chocolate, and also the supplement quercetin, among other things. And it's responsible for breaking down estrogen and particular stress hormones. So you can imagine if there's a weakness or a sluggishness in this gene, there can be quite a number of symptoms, from high neurotransmitter symptoms to intolerance of certain foods and to problems with high estrogen. To point out how common this is, about 30% of the population is homozygous, meaning having 2 variants, basically one from one's mother and one from one's father, on this particular gene in the area that would convey sluggishness. There's another 50% that have one of these 2 variants, and to have this variant could slow this gene up to 80%. Aside from having a variant, another factor that can impact how well this gene is working is how well our methylation is working. So if we are undermethylated, that could convey a vulnerability here because you need methyl to get this COMT to work. So this is where someone can appear undermethylated and thus have low neurotransmitter activity. However, if they have a vulnerability on the COMT gene, they could also be exhibiting high neurotransmitter activity. And so they may have a confusing picture when it comes to symptoms. Or, presumably, they could have these two issues from a neurotransmitter standpoint balancing each other out. But both methylation and a weakness in the COMT gene can convey other health problems aside from neuropsychiatric. And aside from the COMT variant or a methylation issue, toxicity, inflammation, high stress, other environmental issues can impact how well these genes are working and producing the enzymes that we need. And one of the reasons I mention all of these is because these will all be potential targets for treatment. Two good resources for both the COMT and the MAO gene would be the book Your Genius Body by Dr. Andrew Rostenberg. He has a nice section on COMT and MAOA, and the book Dirty Genes by Dr. Ben Lynch. Both of these talk about methylation, but they also talk about the more common variants that are being looked at from both a methylation and neurotransmitter standpoint. So again, I pointed out this in the last podcast episode. This approach is different than the approach of the Walsh Research Institute, which is where the term overmethylation comes from. And I have found in my own work that while I do check the Walsh labs on everyone that I see, and generally that is the starting place of treatment, if I have someone that's not benefiting from the Walsh approach, I do dig deeper and will look for these specific variants to better understand what other factors could be going on. And this allows for the use of other tools that may not come with the Walsh approach. And so I'd like to read quotes from both of these books to highlight how this higher neurotransmitter activity can certainly provide benefits. While a great number of strengths come with higher neurotransmitter activity, so does a vulnerability, especially when under stress. Because when we're under stress, our neurotransmitters will go up, and if we can't clear them easily, then we will be more susceptible to symptoms, but also to stress-related chronic health conditions. So to quote Dr. Rostenberg in his book, Your Genius Body, people with MAOA and COMT are some of the smartest, most intelligent people you will ever meet. The reason is that these SNPs increase catecholamines in the frontal lobes of our brain. If you are blessed with increased dopamine and adrenaline, you will be able to focus like a laser at times, and you'll be very detail-oriented with a good memory as long as the system isn't overstressed. But if your body becomes overstressed from gut inflammation, food allergies, physical exhaustion, too much exercise, vitamin and mineral deficiencies, chronic infections, and the like, you have a recipe for a stress mess. To quote Dr. Lynch, who actually brings in some other attributes which I think are interesting, he would describe potential strengths of a slow COMT: altruism, energy, enthusiasm, exuberance, focus, generosity, and productivity. COMT is also involved in the processing of estrogen, and so this can help point to this being a potential factor. Too much estrogen, which can look like bloating, headache, moodiness, or breast tenderness, can be due to the COMT. Because estrogen fluctuates through a woman's cycle, it can be that those times when estrogen is higher is also the times when there will be more neurotransmitter activity. And if you think about COMT as a funnel, where the more you put into it, the slower things will move through it. And the slower things are moving through, again, the higher neurotransmitters and more symptoms. In a future episode, I'll talk about factors that can contribute to estrogen dominance that very much can relate to this topic. So at least for women, estrogen symptoms in combination with those of high neurotransmitters could suggest a slow COMT. It could also suggest high copper levels, and someone could have both high copper and a slow COMT. And in fact, a slow COMT would make estrogen levels higher, and higher estrogen levels in someone that's vulnerable could develop high copper. And high copper can also cause high norepinephrine or high adrenaline states. So there are labs that will pull for these specific genes that I'm referring to, the COMT, and then I'll talk about MAOA. But I will usually have people do their own 23andMe and then have them run their genome through a couple of websites that will pull for specific genes. And then in looking at those variants, this can help with identifying if the person is vulnerable to a slow COMT, for example, or a fast COMT, or if they don't have a COMT vulnerability. We all have many variants that will show up, and most we'll never hear from. There are people who will take a deep dive into learning and studying about their variants and developing needless stress. So again, I don't recommend this highly or often because we can usually, through symptoms, get a sense of what's going on. And when we can't, this, again, could be helpful. So with regards to treatment, much of what I'm going to talk about will also apply to MAOA, except MAOA does not affect estrogen levels. That's not necessary to break down estrogen. But for both, lowering stress would be paramount because with stress comes higher catecholamines, or these neurotransmitters such as dopamine, norepinephrine, and epinephrine. And if we have a MAOA or a COMT, we can have difficulty breaking those down and then can have worsening anxiety, insomnia, potentially mania, and even psychosis. But we can also have physical symptoms, specifically pain, because when our body is in a fight or flight response, because of those high catecholamines, then we can start to have tightening of our muscles and have muscle pain and or headaches. In addition to increased heart rate, increased blood pressure, nausea, sweating. In addition to lowering stress in our lives, we can also lower physiologic stress, as I mentioned, addressing toxicity and inflammation, but even low blood sugar throughout the day can trigger catecholamines such as dopamine, norepinephrine, and epinephrine being released. So being mindful of that as well, regular meals, good sleep, just basic lifestyle interventions, and working in a practice to help lower stress in the body. This might be meditation or ways of accessing the vagus nerve on a daily basis to really strengthen that parasympathetic or calming aspect of our physiology. And exercise is also an important way for us to break down these catecholamines and to lower the physiologic stress response. Next would be to think about ways to support the COMT gene. And again, this requires a methyl group in order to detoxify the catecholamines, but also estrogen. So optimizing methylation, and that could be using SAMe. It could also, if someone doesn't have low serotonin activity from undermethylation, that could be using methylfolate, B12, and the other B vitamins. The B vitamins I would say are important either way. The exception could be if someone has a low serotonin state, being cautious with folate would be especially important, as folate can further lower serotonin activity. And to learn more about this, I would refer you to my podcast episode on undermethylation. In addition to methylation, we also need to optimize gastrointestinal health and consider how we can lower what's going into that funnel, so to speak. So we can remove catechols, so things from green tea, coffee, chocolate, that could be further clogging those pathways. Dietary changes can be helpful, especially to lower symptoms. These don't always have to be for the long term, but decreasing foods that are high in tryptophan, tyrosine, and phenylalanine. And while there are a number of foods, those that are especially helpful would be to consider lowering turkey, beef, chicken, and cheese. Also, just overall lowering the amount of protein, not unlike I mentioned with overmethylation. We can also work to lowering xenoestrogens. So those could be things in plastics, herbicides, or pesticides. There are specific nutrients that can be helpful in breaking down catecholamines, including niacinamide. Now, this is a supplement that I also referenced in overmethylation. Melatonin has also been shown to lower norepinephrine, epinephrine, and dopamine in the brain, and can lower cortisol levels. L-theanine is another supplement that can be very helpful, as is magnesium. Aside from addressing estrogen dominance and added estrogens, we can also use interventions to balance estrogen and progesterone. One example for that would be using a product called DIM. So the other gene that I'd like to talk about related to this issue of failure of the neurotransmitters to be broken down is MAOA. And it's very similar in some regards to COMT. However, it's not involved with estrogen. And unlike COMT, MAOA is also responsible for the breakdown of some serotonin. So we can have high dopamine, high epinephrine, and high serotonin as a result of a slow MAOA. And what that can look like is aggression. It can look like difficulty slowing down, problems falling asleep, having very long focus times, and this goes along with having that extra dopamine, and so that would apply to COMT as well. If we have too much dopamine can be toxic to neurons, specifically those that involve dopamine, and so we don't want to have toxic levels of dopamine. So to evaluate this is similar to how we might look at COMT. We can look at someone's symptoms in the context of either doing a 23andMe and pulling for particular SNPs, as we call them, or variants, or there are some labs which will pull for the more common variants that affect neurotransmitter activity. Treatment is to, again, support that particular gene and enzyme. And in this case, B2 is particularly important. And in this case, also decreasing foods that are high in tyramine. And this would include foods such as fermented foods, pickled foods, aged foods, foods that are dried, such as fruit, alcohol, soy, and fava beans, and various sauces. And again, as with COMT, this one can be either fast or slow. When it is fast, and thus the person is having a depletion of their neurotransmitters, there can be high carb cravings because of the low serotonin, and there can be a vulnerability to addiction, which I'll talk about in a future episode. If you know someone you think might benefit from this information, please consider sharing. If you'd like to read more about other root causes to brain-related symptoms, please visit my website at CourtneySnyderMD.com, where you can subscribe. I'm also on YouTube, Instagram, and Facebook. Please consider liking, sharing, or commenting if you'd like to help me get this information out into the world. Until we connect there or in a future podcast, take care.